So what we're going to talk about today is temperature, heat, specific heat capacity, and calorimetry. All right. What is temperature proportional to in terms of energy? It is the average amount of kinetic energy that molecules have in a substance. Okay. What is the definition of heat in terms of the physics? It is the energy that flows from something hot into something cold. It's the energy in transit. Okay. Common misconception. Sorry. Unit is joules. It's an energy. Okay. Common misconception is heat. Sorry, the hot objects have heat. Like, wow, that's really hot. Must have a lot of heat. Nope, definitely not. So, correction, hot object contains a lot of internal energy, which we'll talk about here momentarily. All right. Which way does heat flow? Naturally, it always flows from hot to cold. So a thermal equilibrium is when two objects have the same temperature. At that point in time, we say that heat does not transfer between them. So at thermal equilibrium, no heat transfer. So internal energy, we alluded to that. The variable for that is capital U, and it is the total amount of kinetic energy of all the molecules added up in a substance. Has units of joules, it's an energy as well. So at absolute zero, the internal energy is also equal to zero because that is when all molecules stop moving at absolute zero. So wanted to compare that to temperature, internal energy and temperature. So temperature is the average amount of kinetic energy molecules have. So it's focusing on how much energy there is per molecule, how much, not the total amount. Compared to internal energy is the total amount of kinetic energy that all the molecules have. It reflects on how much thermal energy there is for a substance or object. So the more molecules you have, the more internal energy you're going to have. Specific heat capacity. You might remember this from chemistry. It's how much energy is required to change 1 kilogram of material by 1 degree Celsius. So it's likened to or compared to thermal inertia of a substance. So it's how resistive 1 kilogram of a material is to changes temperature. So what does it mean if it has a high specific heat capacity? It means it takes a lot of energy to increase the temperature of a certain amount by 1 degree Celsius. So what's a substance that has a high specific heat capacity? Water is definitely the most popular example of this. Has a huge amount of has a really high specific heat capacity, and those that have low, metals is a common one. What is the equation that describes how much energy is taken out or put into an object to change its temperature? This is Q is equal to Cm delta T, where Q is heat, C is specific heat capacity, M is mass, and delta T is change in temperature. There you go.